Hi guys, hope all of us are doing great. My name is Ernest. I'd like to welcome us to our TV of Ernest's Sciences and Mathematics TV channel. In our channel, we deal with the different aspects of mathematics and sciences. And of course, we try to look at different areas in these specific subjects. And in our discussion, we also involve the concept of tackling some of the problems which are accompanying these specific discussions. So in a sense, I'll like to encourage our members to check on our various contents that we have uploaded in our channel, and also check on the description boxes of various videos that we have done so that we can be getting updates on our various areas of discussion. So in a sense, today we are going to look at this specific kind of reaction, which is electrophilic halogenation of these unsaturated compounds. And this one, in a sense, I picked this topic because it is quite relevant in our day-to-day applications, of course, in some areas which I'm going to mention. So before we look at that, we had earlier on looked at what basically consists of what we refer to as organic reactions. And I've mentioned that this is basically a class of organic reaction that we refer to as an addition reaction. Later on, we're going to look at the different types of reactions which are going to accompany this kind of discussion. And basically, some of them we have already looked at them in some of our videos, basically, maybe in their areas of application or maybe in some of the questions that we have tackled. So therefore, I'm not going to mention much of this, but in any case we come across these kinds of reactions, then I'm going to mention under which category they fall, just as I've mentioned that this one basically falls under the category of addition reaction. So basically, these are the broader categories of chemical reactions that I've mentioned or we have tackled in one way or another. And our last one, and the last one is our area of emphasis for today. Now, these organic reactions involve some aspects that, of course, we refer to as a mechanism or reaction mechanisms. And this basically implied this step-by-step sequences or steps, elementary steps that, of course, are being involved, which result in the overall chemical changes which are taking place in organic reactions. So therefore, I'm going also to involve the concept of reaction mechanisms wherever we are going to talk about this particular kind of reactions. Now, if we try to give this one basically a historical context, there's some procedure or kind of priorities in a sense that we're going to consider whenever we're going to talk about this halogenation reaction, which basically is an addition reaction. Later on, we're going to see the effect of what we refer to as a nucleophile and generally an electrophile, which I've defined in some of our videos and given them the initials for, of course, those particular symbols. So in a sense, from the concept of a charge, we can be able to look at this. This is an electron-rich species, while this is an electron-deficient species. Therefore, from these particular names, the concept of phylus or phile refers to the electron-loving species, and this is an electron-rich species. So therefore, whenever we are trying to consider this aspect of a nucleophile and electrophile insofar as halogenation is concerned, then therefore it's going to follow in that specific order that they are going to react with the particular points which are bearing the opposite charges of those particular molecules. So going forward, then we are going to look at basically what electrophilic halogenation entails. And from this particular case, we're just going to do that using an example. So I've said that halogen addition basically falls under the category of, or rather halogenation falls under the category of organic reactions. We're going to see, and in this type of reaction, the halogens, we've talked about the periodic table and the concept of halogens. Therefore, we're going to use this particular symbol implying halogens. The halogen molecules basically are going to react with the alkene and alkyne molecules, which we can just give as functional groups of those particular illustration for 1 and 2 respectively. So therefore, the first one is going to imply a double bond, and the second one a triple bond for these two classes of organic compound. So generally, therefore, we can just give an illustration using the first one. Now, suppose we have a double bond that is reacting with the halogen. In this particular case, just going to use this symbol that we had. So it's reacting with the halogen in this particular case, and this is a diatomic molecule. So therefore, this is going to form a product which is going to have this specific rearrangement. So in a sense, if you try to figure out or try to compare the reacting species and the product, therefore, we can be able to visualize that there is an effect that is happened on the double bond. So whenever this kind of products are formed, these are going to be referred to as the fissional dihalides. And this fissional dihalides from our nomenclature, of course, basically refers to the concept of having a compound that has got halogen on adjacent carbons, just like this. For instance, if we were to name this one, then we could have the sequence of 1, 2 dihalide, which is a general nomenclature for this kind of a halide. So therefore, a 1, 2 dihalide is going to be referred sometimes to, or in some of the literature, fissional dihalides in that particular case. So therefore, if we try to interpret the concept of this particular reaction, and therefore we are going to see that there's going to be some kind of a bond blockage and bond formation in this kind of a reaction. We had said that whenever new compounds are forming from interaction of other compounds or other molecules, then therefore there's going to be bond blockage and bond formation. Now to just try to create an elaboration on this, I've mentioned that carbon basically forms bonds through covalent bonding. And in this case, if we have an alkene molecule, then therefore we accept that the interaction of this is going to occur by sharing of valence electrons. And if in a sense, if we talk about the concept of electron, then we have discussed about the atomic orbitals, which we are going to consider in this particular case. So the interaction of atomic orbitals in the valence shells, then therefore is going to give us a concept of the head-to-head interaction of atomic orbitals, or lateral interaction of atomic orbitals. Now we had specific names that we were using to describe this concept of a head-to-head interaction and a lateral interaction in our video on hybridization of atomic orbitals. Now for head-to-head interaction, this one we give it a symbol of a sigma bond. Whereas for the lateral or coaxial interaction of atomic orbital, this one we refer it to as the pi bond in that particular case. Now in our halogenation reaction, which I've given a general representation, we're going to see that in this particular case, there is going to be a pi bond that is going to be broken, basically, which was this particular double bond, which is going to be broken, and two new sigma bonds are going to be formed. Now, therefore, we're going to have a lateral bond that is going to be broken, and we're going to have two head-to-head bonds which are going to be formed in this particular case. Now, therefore, this kind of a reaction basically occurs in these two classes of organic compounds that I've given for double and single bonds, respectively. Now, in this case, we are going to also to see that in trying to expand on what basically this kind of organic reaction entail, it will inform the formation of an electrophile that we are going to symbolize from this specific species of a halide. And this, therefore, we can refer to it as an electrophile. Now, this formation of an electrophile is going to be accompanied by the interaction between the electrophile and the double bond, whereby the double bond is going to be on the electrophile. And therefore, if we had this symbol for this particular compound, then therefore we are going to expect this influence of an electrophile, which is a positive charge, therefore, being transferred into this particular double bond. And therefore, this is going to lead to the formation of what we refer to as a carbocation. And this carbocation is going to form an intermediate state that is going to lead to the final product. Now, suppose we had that one in an illustrative way, then therefore we are going to have this particular compound, a double bond, and this is going to interact with the, let me just give it somewhere up here. This is going to interact with this electrophile that has been formed, and it's going to pick on that electrophile, and therefore this is going to lead to the formation of what are referred to as a carbocation. So therefore this is going to be attached at that specific point, and we're going to have this specific center a carbocation with that a positive charge at that particular point. So therefore in this particular case, then therefore we're going to see that there's going to be a subsequent step whereby, so this is the first step, there's going to be a subsequent step which is going to have this electrophile which is has been formed interacting with an electron-rich species, basically which is going to be an ion. We can just give it an example of that particular set of an ion, and then this is going to react with this electrophilic part, and this is going to lead to the formation of a final product, which basically we refer to as a fissional dihalide. So therefore we're going to have this final product which is being given as YX as such. So we expect from this particular kind of a combination to be experienced by both the alkenes and alkynes, and therefore that basically implies the concept of electrophilic halogenation of alkenes and alkynes. Now, as I mentioned, of course, this one finds wide applications in various areas, and therefore we are going to look at this going to refer to a nucleophilic attack. This nucleophilic attack basically we're going to see it being widely applied in some of or rather being explained in an exclusive way in some of the reactions that we're going to refer to as SN1 kind of reactions in part of our videos which are going to follow. In reference to that, of course, I'm not going to expand on that, but basically this is one of the reactions that is going to be observed in some of the nucleophilic reactions that we're going to basically see. And the nucleophilic reactions, of course, this and the related compounds were heavily discussed by the likes of Christopher Ingold and Sir Christopher Ingold and Edward. And later on, we're going to see that also there are some other scientists who were involved in this particular case in trying to study these compounds of alkyl halides and their various properties. So for now, we'll just stop there. We shall look at other organic reactions in our subsequent videos, which are going to shed more light on how we can be able to approach this kind of topic. So that is it for now, guys. Bye. God bless you.